Alright, time for another DraftScience video presentation. Up all night edition. Water hurricane, went by and, I don't know, 12 inches of rain. There's things outside that have pretty flat sides and they have more than a foot of water in them. Like a standard 5-gallon bucket. You know, it's it's got 5 gallons of water in it. Stuff like that. Just an insane amount of rain in like 5 hours. So, I've had to be vacuuming in the basements, a little bit of seepage. But nothing horrible, but just you know, wet over there, and it's wet over there, and it's wet over there, a little bit over there. But anyway, just Anyway, it's a part of the fun. Of life. Anyway, so um, knocked over a fence down the street. I guess it was like 3 feet of water just down the road. So lucky in a way. Anyway, so I'll read a couple of comments that are pretty stupid, and so that shouldn't take too long. Maybe I do it in pieces in between vacuumings. I was using a sponge and a bucket. That was really uncomfortable. Yeah. Anyway, show your face or you're a coward. Well, the point is, if you're going to do all this ridiculing on the internet or doxing and all this kind of stuff to people, then you ought to just demonstrate that you don't mind being in the same kind of jeopardy and being exposed to the same kind of trolling. So that's the pussy part. So if you're going to participate, even in comment sections, and you're a coward, you're going to participate by using somebody's real name and doing other things that are just, kind of invasive, then yes, you're a coward, you're an asshole, you're not a nice person. So, and he says, if you aren't anonymous on the internet, you're an idiot. If this is how you think the planet Earth is going to get better, is by people being anonymous and unaccountable, you're really full of shit. Okay, so you're an idiot if you think fake news and unpunished crime is good for society. So you're an idiot, in my opinion. Fucking idiot. I'll just add that. I usually think idiots are fucking idiots, and you're a fucking idiot. Anyway, I mean, to make excuses for the particular people I'm talking about who, again, are playing, or abusing the fact that other people have exposed themselves to this manipulation, where their videos can be distorted and they can be quote mined and all this other crap that's done. I'm just saying it's just so cowardly for people to take advantage, of that when they aren't exposing themselves to the same jeopardy. Alright, it's like people who haven't died yet telling other people life is fun and easy and just no problem at all. It's kind of bogus for people who, to get pregnant when they haven't died first and proven it's no problem. That's kind of bullshit. They're idiots. Alright, I don't truly get the paradox thing. So this is the JPG Richie guy. Now, this is, I did make the accusation that he's Farley the Troll. I called him JPG Cowboy in the last video. So, and he's not even responding to that. So it seems pretty clear, yes, I've outed you. Okay, you're just trolling. You're just a fake person pretending to play a fake role in some kind of, fake conversation. You're just fake newsing. And fuck you. Alright, so he says, I truly don't get the paradox thing. So again, the video just was full of it. I mean, I pointed out how there's two choices. Professor Lewin did a shit experiment, or there's free energy. But there's no other choice here. Their mathematics is insanely stupid. Okay, because it basically says free energy is real, and yet none of them decided to do any experiments to take advantage of the free energy they discovered, which is pretty hilarious. Do you believe that? or that for 300 years the free energy perpetual motion machine was easy to make and nobody could figure it out. That's called a paradox. I pointed out that there's no third finger here anywhere. There's no other options available. And I pleaded, if you have some available option besides believing Professor Lewin cheated or there's free energy, if you have an other option, I would like to hear it. I mean, I did all of this. I mean, I can play my video, like especially from 26 minutes on, right? I could play that little clip anyway. Do I really? Well, maybe I do need to do it. I mean, it's just so stupid. This argument is so insipidly stupid that I don't even know how could you possibly play a role? You're so idiotic and dumb. I mean, I overtly did it to you twice. I have instructed you on this function, and you're saying, you're pretending you don't understand? You don't understand that when something has more momentum, like when momentum isn't conserved, you get more momentum, that's free energy. Momentum is, in fact, energy. Whether you want to call it kinetic energy or not, it doesn't matter what you call it. Mass times velocity. If you make more mass times velocity, you have made more energy. Fuck tard. Shit. You keep saying the professor video shows a paradox. Yes, it shows the creation of extra energy. If they're going to conserve kinetic energy, the heavier object can only have half the velocity. If it has 2/3 of the original velocity, it means it's increased its momentum. The object moving this way has increased its momentum. Now, the fact that there's another object going that way doesn't mean a damn thing. That's not going to make that thing slow down over here. The thing going this way has more momentum. If it was an arrow or a cannonball, you wouldn't have any problem understanding I don't want it to have more momentum. If it keeps gaining momentum and it was heading for your house, you would say, please do something. Stop it from gaining more momentum. It's going to hurt me. So this is moronic. You don't understand that increasing momentum is increasing energy. You don't understand. It's mv. That's the same thing used in their formula, except they square it and they put a half in front of it. The half in the squaring doesn't change the fact that if the m or the v goes down, kinetic energy would go down too. So this is essentially creation of kinetic energy. A certain amount of kinetic energy in the sense of a certain amount of mv, the core of the kinetic energy, went in, and you're getting more mv back out. That means you have more momentum. That means you have more energy. Give me the layman explanation. I mean, it was in the video 17 million times. So, I mean, at least 4 times I went through the explanation. At least. And that's in that video. Let alone all the other previous videos I've done on the subject, which you could easily research, of why there is a paradox. Free energy or Professor Lewin cheated. Those are not two reasonable choices. It's really not reasonable to think Professor Lewin put a shorter strip on the heavier object, right? If he put a shorter magnetic strip, it's supposed to be 10 centimeters, and he only put 8.5 centimeters on the larger object, well, then it would look like it went faster, you see. But it has to be a cheat like that. Like he forced the experiment to meet the mathematics. I'm not willing to say I think Professor Lewin is capable of that. But I'm just saying the alternative is free energy. Don't tell me you've explained it before. Why shouldn't I tell you that? That's why I'm here, is to explain things, but I'm not here to explain them to people who are belligerently stupid. And you have to be belligerently stupid not to understand the paradox. Even if you don't believe momentum is meaningful, you have to understand that if I do increase momentum and eventually double the momentum, that I've done something rather significant in terms of I have to account for where I got the energy from. You can't get free momentum. momentum is supposed to be conserved. Those are words that come out of Professor Lewin's mouth. He believes in the conservation of momentum. He even says you can't screw with momentum. Nature can screw with kinetic energy, but it can't screw with momentum. He says these things. Don't tell me you've explained it before. Fuck you, when it's clearly the answer. Clearly the answer. Just go ahead and explain it again. Why? You're just demonstrating the audience you're saying is too stupid for the conversation. You're too stupid. You don't understand that if the elephant that's going to sit on you weighs more, it has more momentum, its ass, that's not good for you. And if it got that for free, it just magically got heavier and heavier, its ass, from nowhere, you'd understand that, well, they can't do that. Phrase it in a concise way. The whole video was concise in the sense that it was, 20 minutes. But I made a 1-minute video on the subject. So I'm not doing this for you. Okay? This is absolute nonsense. I can pass along to others. Sorry, it's not a phrase. You have to understand what momentum is, and you have to understand that you can't create free momentum. Some of these others don't think momentum has to be conserved at all. They think it's just a magical, weird nothing. They don't think it even exists as a meaningful concept. So it's not going to mean anything to them. They think it matters whether something's going this way or something's going this way. They think this is a minus direction and this is a plus direction. And somehow if the two things are going in the opposite direction at a speed, there's no speed. Nothing's going any speed. Nothing's happening in the universe. Because they somehow cancel by some magical way. So I throw a baseball that way, and I throw a baseball that way at somebody's head. Somehow, they knew the baseball was going to hit anybody's head. Nothing, no harm, no foul. No energy was involved. Nothing happened. It's an absolute pile of shit. Pass that on to others. That they're full of shit, if that's what they believe. Just tell me, there's a paradox because fill in the blank. I said there's a paradox because we have two choices that are not reasonable. Free energy, undiscovered by all the morons seeking it for all these years. Hundreds of thousands of crazy little Robert Ritchie moron-y type people searching for the free energy. And they didn't fall on this obvious pile of, just use their mathematics and follow the recipe and you have free energy. So just bang light things into heavy things and you'll keep creating more and more free energy. That's why there's a paradox. So I hate to say, I really should, I'm just going to block you because you've proven you're the troll. You've proven you are just Farley and you're just, doing an unseemly act, in my message board. You're just playing a game, fuckhead. If you don't get it, you can't get anything meaningful in this conversation. You can't understand any of these concepts if you can't understand that claiming momentum isn't conserved is a dramatic claim. All right. Anyway, it's it's basically saying Newton's third law is shit. It's doing a lot of things. And it's clearly creating energy out of nothing, which is really silly. So, fuck you. We're blocking you. Yeah, we'll choose the blocky one. Just make sure we did it right. Okay. So another guy points out that the frozen recording time is what was in Mindless Marbles video. That's why the video wasn't playing. So I said, why isn't the video playing? Well, it's because that was the video of mine that was broken. Okay, so fine. Not very relevant. So instead of actually engaging any issues in the conversation, which is the terrible quality of Stephen Bro's experiments, instead they do this. So I will point out, somebody has made it known to me, okay, that Stephen Bro does claim that he didn't change the speed of the clips, the two comparison clips. that means that they were going just about the same speed, especially at the midpoint. So they had already achieved about the same velocity. And that means that you're basically saying my argument's correct, that the faster object lost its velocity rather dramatically and rather quickly, and that it didn't do what it normally does, which is go twice as far. So maybe that they should show us is that, you know, the lighter car should go twice as far because they use distance to tell how much energy there is. It should have gone twice as far, and I bet it didn't. I bet it didn't go anywhere near twice as far. I bet it went about as far as the other cart, because guess what? The energy they were giving up was proportional to their velocities and their masses. So the lighter car was in fact braking harder than the slower car, and because it was losing more energy more quickly. And so it would die out quicker, and it wouldn't go twice as far. And that's pretty much what I think Stephen Bro's experiment will prove. So if he had the lights on and you could see how far the cars go, you'd see that they don't go dramatically different distances. One of them doesn't go twice as far. So, but anyway, we didn't see any of that. We didn't get any of that. Because we had a 1 minute physics video. 1 minute experimental physics video. Somehow people think that's the way it should be done. You shouldn't see anything. You shouldn't see how anything's done. You should just see the conclusion. Here's the finish line. See, our guy won. See, physics always works. We don't get to see anything. Alright, how you reach that conclusion. Alright, so I will go back to work and see if there's anything else later that I feel like throwing into this video. But nothing's really occurring to me. Yeah, I don't hear it. I did like the ghost analogy for the way energy is transferred, but I was a little bit wrong to say the ghost won't give up his head, because that's actually how it happens. The ghost will give up energy as long as the object it hits can move. So if it moves some amount, you'll give up that amount that it's willing to move, But that's the problem is that it can't. Heavy things can't go fast, and so when something's going fast, it's like the force moves right into them, but because it can't move the atoms at that speed, the force has to reflect. It doesn't have a choice. It has to reflect back out. But they don't have any counter theory. There's no theory of how force moves in any of these kinetic experiments. Absolutely none. They don't have a theory for how energy is transferred from one object to another object. That's why they think friction is actually a counter force. They actually think it's a counter force. They don't think the actual force is just you losing your force. Your momentum is being transferred to the little objects in the environment. And by transferring your motion to them, you don't have the motion anymore. Why don't you just propose that to them and have them give you the counter explanation, that it doesn't really work that way, that it works some other way, that everything that happens, heat or friction or direct transfers like a bowling ball hitting a bowling pin, these are transfers of energy. One object gives the other object its energy. So whatever energy it leaves with, the object that gave it the energy loses that much energy, that much momentum. I mean, it's so obvious that that's the truth, and I don't think there'll be any counter theory that that's exactly how it works, and that's why kinetic energy fails, because kinetic energy always says the little stuff I hit will never add up to the amount of energy of the one object going fast. When I break it into little pieces, I won't have as much energy. Alright, anyway. We'll pause and we'll see if there's anything else to throw in. I don't think there will be. I mean, Piro made a video. Piro's made a couple of videos, and they're just horrible. I don't know what he's doing, but it's just so bad. He's pretending to do a bad show on purpose to mock shows, I guess. And, you know, but in some ways arguing that he's, you know, and he's almost mocking the idea that conversation is at all useful on the internet, because he's almost mocking the whole idea of what persuasion requires, and, you know, how you have to, you know, make some effort, you know, to make your argument well and concise and all of these things. And he's not even trying. And, you know, it's just yuck. So he's not making any physics arguments, so he's very irrelevant to this page anyway. All right, so anything else? I don't think so. Not at this time. So, pause. Alright, I thought I could just throw in some stuff. Also heard Stephen Bro said something about some kind of crap that I should itemize for him, a parts list and all kinds of specifications for how to do experiments. And that's fine, but first you have to agree on the experiment. You know, what are you trying to do? And, you know, there was no itemized list was necessary for you to understand that you can't measure total momentum instantaneously at different times. You know, that you have to collect all of the energy if you're going to say one thing has more energy than another thing. And, you know, that was such an obvious error on your part not to realize that fast things give up their energy in bigger chunks. Now, it depends on the medium. If you put a fast thing in clay, it doesn't do that. But that's the whole argument, that some mediums have a bias for velocity. But most mediums, okay, like friction doesn't work either, right? If you go the faster you're going, the less friction will get in your way. So, but clearly friction gets substantial when things like terminal velocity, like the friction overcomes every little increase in your velocity that could possibly be made. And so you can't increase your velocity past a certain maximum, and then air resistance is, you know, takes care of every bit of increase. It counter forces every bit of increase. So there's always circumstances, and you just don't want to hear about any of the circumstances that have to, you know, the real mechanism. And they also said something like chalkboards are no good. And I shouldn't write on a chalkboard. I shouldn't explain things on a chalkboard. And that's, you know, like the most used way to explain modeling theories. I mean, all the professors use them. Even ones doing philosophy use chalkboards. So that's really a dumb thing to say, in my opinion. So anyway, so a simple experiment that I think gets to the core of this, all right, would be just to use the lever instead of the spring. But you have to test it first, right? So you have to make a lever with a nice little bearing and, you know, nice rigid arms, and it has to be light, you know, lots of rules. So aluminum or something, blah, blah, blah. Take as much bend out of it as possible, make it as good as a scale as possible. So you're just really making a scale, all right, and a nice one, okay? So that's the rule, a nice scale. And the idea would be is that we're basically saying, you're saying that a bunch of energy gets lost when we convert, you know, an 8 mass thing going 16V, you know, versus a 16 mass thing going 8V. And the truth is, the lever will tell you. You can convert them one to the other, but you can convert speed. You can change their mass to velocity ratio, okay, with a lever. A lever can make you think you are heavier than you are, right? I put a weight on here on the scale, and I put the weight out here, the same weight, it weighs more out here, okay? And it will travel more distance. It'll go a lot faster velocity. And, you know, so I can move things on a lever and convert their MV. So I can make two things that don't have the same mass, okay, where the masses are different. and I can make them appear that they have the same mass. Okay, so I can make this a 2x object, and I can put a 1x, mass, a 1 mass object out here, and I have a 2 mass object there. I should have made this bigger, or I should make that smaller. Can't really make it smaller because I didn't make that one very big. Okay, I put a 2 mass here, and I put a 1 mass here, and the scale will balance, saying they're the same. So this is halfway. Okay, just to let you know. Right? So once we know that principle, then we can just do this. So we can take the fast cart, right, that's got the higher velocity but the lower mass, and convert it, okay, into the slow cart. So we can put the 2 mass cart here, right, because we're going to balance the masses now. So and we put the half mass here, right? So the 1 mass is here, and the 2 mass is here. So I have the cart stationary here against the lever. Probably the lever should be back a little, but who knows. How much time you'll need to push the cart is an issue I'm not sure of. So you test it first with just 2 carts, right? They're exactly the same. You put a cart here, put a cart here. Well, you don't have that many carts, right? So that's the dilemma. Yeah. So that takes all the fun out of it. No, you can do it because you can just make two mass carts. No, you only have 1 cart. Right, you have to make it a 2 mass cart versus a 1 mass cart. So yeah, you can't really do this. So never mind. Yeah, but I'll just finish explaining. So the simple principle would be, so you have to find something else to push that's the same for both objects. So it doesn't really matter what you put here. I guess you could put a round ball and see how far it rolls. That will probably work. It's not as efficient, but it will probably work. So you put a round ball here of some mass that's not insubstantial. All right, and then you put the cart that's going fast, that's light. You put the light car, the 1 mass car. Okay, you have it hit out here on the lever. Okay, the one with the faster velocity, because it's going to push this, it's going to convert the velocity. So it'll double the velocity, and that means it can't change the mass, so it'll give it the force proportional to that. And you just hit here with the object that has a 2 mass, okay, but the slower velocity. You hit that one here, all right, and that'll do the conversion again and push the object, right? I don't think there's any dispute about that. The 2 mass object here's the same as here. Yeah, well, that was the 2 mass weight, so that worked out okay. So these are the 2 positions. And if it was a car here, then you would be able to see that it's equalizing. I pushed the heavier car inside, I pushed the lighter car on the outside, and I should get the same result. So if I put the 2 mass car here, it would get pushed at, it would end up going 8 miles an hour, all right? And if I hit the 1 mass car, that's what I get. And if I hit the 2 mass car at the same location, obviously I get the same speed back out. So that's not an issue. But that's what you should do. That's the experiment that would be interesting. Like I said, ideally you have to have more than 1 car, because then you could test it by just putting a car in at the same location and seeing if it leaves with it, so you didn't lose. See how much energy you lose. See how inefficient your lever is. Would be the first test. Anyway, all right. So that wasn't. I thought there was something there useful, but there really isn't unless we get a better system for giving objects momentum. Because again, relying on rolling things is a problem, because then you turn the momentum into angular momentum, and you can't measure angular momentum nearly as easily. So you don't want to do that. You can't measure it by just measuring how fast something's moving. So anyway, they'll have to rely on something else. But whatever. But these are the simple tests. You're saying that this lever loses, that somehow if I do this experiment, I'm going to get this 1.4 thing is going to happen. And I'm saying it's impossible. If you logically analyze, there's no 1.4 thing going to happen. There's no way you're going to prevent the momentum from being equal, being conserved. Because momentum is always conserved. So you're going to lose the argument. Anyway, I'll pause again and see if there's anything else. Hopefully it'll go better than this little section did. I guess I should point out, just because some people might not realize, levers don't make energy. They don't make you stronger, technically. They're changing the rate, the time it takes for you to do an activity, and by giving you more time to do it, it makes the activity seem a lot easier. So if you can move 1,000 pounds by just taking 10 pounds at a time, you can move 1,000 pounds. But if you try to lift 1,000 pounds, you're going to be hopeless, right? But a lever makes it possible, because a lever actually turns it into little bricks for you. You can use levers or pulleys, and you can convert the 1,000 pounds into little chunks of weight. So, but levers don't make energy. They can't make anything have more momentum or more energy. It doesn't matter where I put something on the lever, where I hit. I can't make it make more energy. I can just convert it into different ratios, but I can't make more energy. Momentum in one side, momentum out the other side. That always has to be equal. Alright. Now that should be enough stated. Momentum in one side, momentum out the other side. Yeah. Yeah. Anyway, I have to think about all this stuff because I'm frankly a bit tired. But anyway, okay. Pause again. So I did think of something to add. I didn't have any other videos, so I've been saying it's a 16% in the Professor Lewin paradox. Increase in the momentum. So it's in one direction. But I mean, obviously, see, this is, I got some stuff from Mr. Natural. And one of the things I got was a physics book, a little textbook. And the first section was on scalars and vectors. And it's just so funny because they put speed in the category of being a scalar. And then they put velocity in the category of being a vector quantity. And obviously you know that whenever you say one of these things, you say them exactly the same way. You understand that speed always has a direction. So it's just so silly to say speed is different than velocity when you always describe speed as like 25 miles per hour. And, you don't tell person, well, north, northwest. You just say that way or whatever. But, I mean, you always know it's in a direction. It's not 25 miles an hour in any direction. So it's just ludicrous and silly. So anyway, so this idea that there's such a thing as a negative momentum is just retarded. All momentums are positive. It's just retarded to sit there and pretend they're positive and negative. And all they can be is canceling, like constructive and destructive interference. So yeah, they cancel, but it doesn't mean that the cancellation means they didn't exist or that the energy isn't actually going somewhere. So when you shoot it out of a rocket, yeah, it ends up being, canceling energy in the sense that you end up with a zero because, you can put 10 over here and 10 over there, and it's not going to make you turn any. But so what? It doesn't mean that 10 isn't going to hit something. It doesn't mean it's not real energy is all I'm saying. It's not real velocity. Of course it is. So anyway, so 16% in this direction, and you gain 33% in this direction. Okay, and the idea is that when the car came in, it has a certain vector, a certain amount of energy. It's momentum, mass times velocity. It has a certain mass and a certain velocity, and that's a total amount of energy. And you're basically saying, when I have the interaction, I'm going to increase that by 16%. And that's obviously, if you can keep doing that by just putting a heavier object, 100 grams, 200 grams, 400 grams, 800 grams, and you'll just keep increasing by 16%. So the 16% is, the expectation would be that if I double the mass, then I have to halve the velocity. That's a Professor Lewin equation. It's an equation he puts in a square box to emphasize how it's always true. Okay, V1, V2, proportional to V2 over V1, whatever. It ends up being the same thing. Mass, velocity ratios end up being the same thing. Kinetic energy is conserved and otherwise. So it's a fundamental thing. And so your expectation is that the twice as massive object will leave at 1/2 the velocity. So the difference between 1/2 and 2/3, the real amount it leaves, that's 16. That's the point. That's the 16%. So you're supposed to only be able to get to 1/2. That's the maximum speed you can get when you double the mass. But instead you've got 2/3. So you've got an extra 16% in your velocity. And that's a problem. In terms of that's free energy. And again, it happens each time you do the experiment. So I guess that should add clarity to some people who might have been, where did I get the 16% from? Doesn't mean much. Like I said, the other one goes one third this way, and 1/3 of the velocity obviously would be 33%. Yeah. So, but in the experiment, as we saw, the one catch is that somehow the first cart, it's going fast to hit the big cart, right? But it bounces back, and so it does this bounce back at 1/3 the speed, and this event happened first, even though this cart was going 2/3 the speed. So this one should have technically been able to get to the detector. It did look like it was pretty much centered between the two detectors. This one should have got to the detector first. It's going 2/3 the velocity. Should have got there first, and this one did. But that just might be because the springs are what's creating this 33%. This has nothing to do with the object. It just has to do with the springs expanding and pushing the item the extra third. So anyway, all this extra energy was being created by the springs. The question is, can springs create and store free energy? That is, energy that's used twice. Can you compress the spring and at the same time move the object? Because that's what you need to do to make this work, to be right. And if you can do that, then it is perpetual energy. Which doesn't make any sense. Because again, too many people have been looking for it, and it can't be this easy. I mean, on top of all the other things I've demonstrated and proven and made logical and made apparent, I'm also going to invent the first perpetual energy machine. I mean, just come on. That's just way too many Nobel Prizes for one man. Just way too many. Anyway, okay, so that's more video. I think that's probably enough. So I think we'll just get the hell out of here, and I'll go about my business. And kind was your business. Blah, blah, blah. Yeah, fuck them assholes. Animals are my business. People fucking suck. So, till the next video and such, I guess. I don't know if I really need to end the video yet, so maybe I'll just wait. Wait, see what happens. Yeah, maybe there'll be a power failure, lose the video, but worse things have happened. Yeah, so maybe I'll wait. See if there's just some little extra bit. Alright, decided to throw in this little bit. I'll play some of my previous videos. This is the, JPG Cowboy, and then he says he wants this to be made more explicit, this paradox. So the rest of this whole video, the last 20 minutes of it, are just on that subject, and this is how I introduced it. And he just still says he's claiming he doesn't understand why there's a paradox. I don't think your theory that they're credible people trying to do decent things
is a reasonable theory.
There we go. Well, that's a little extra bit thrown in.
Okay, so fuck you.
Yeah,
All right.
also.
Alright, so let's go. We'll go to the Professor Lewin paradox video one more time. It probably won't be the last time. There hasn't been a single response from anyone explaining it. Not one single explanation at all.
Okay, so I've made at least five videos on the subject, and they've been really pointed in that they've just been on that subject. And there's no comments explaining what the catch is. How free momentum isn't free momentum. How you can make something heavier in a direction and somehow it cancels because there's something heavy going in that way. So I'm making an elephant bigger and bigger and he's going that way. And because there's a rhinoceros going that way, somehow it doesn't matter. Yeah, it does matter. It doesn't make any sense.
I mean, I tried to venture an explanation by saying, well, maybe the spring is going in the same direction as the cart, therefore it's collected energy, but it doesn't change the free energy outcome.
Right, so the spring accounting for the extra 1/3, going both directions to get to 2/3. Right, but 2/3 still is only 16% more than 1/2, so it still doesn't make any sense. So those two equal contributions don't really add up anyway. You can see what I'm saying, right? You could say if 1/3 of the energy goes this way and the spring was adding another third this way, that could make sense, right? But it can't make sense because it's not 1/3 extra this way, it's only 16% extra.
So my explanation doesn't work because it doesn't explain why it's not free energy. So we only have two choices here. You either say Professor Lewin did a shitty experiment and got bad numbers, or you say there is free energy. That's it. There's only these two options. If somebody can explain how there's some third option here somewhere.
So he somehow wants me to provide the third option that I'm stating. I can't see it. I can't find it. I can't find any logical way to escape either the conclusion A or conclusion B. You're saying there's a possible conclusion C. I don't see a possible conclusion C. So unless you can show a possible conclusion C, I don't see how you can miss the fact that this seems like we're stuck in a paradox where we have to, make accusations about fake physics done by Professor Lewin, or we have to concede free energy was always really easy to find and nobody found it.
Please provide the explanation, because I can't find it. I can't find any way to weasel out of this except Professor Lewin did a sham experiment, or there's free energy. There's no other option.
So in the video, I go through the process in some detail of explaining the theoretical way you can take advantage of the extra momentum in the direction and how you can create a machine that will just keep increasing the momentum by just banging light thing into heavy thing, light thing into heavy thing, light thing into heavy thing. And then you just go into a lever to convert it back into a light thing again, technically, with twice the velocity. And then do it again, and do twice the velocity again, and then twice the velocity again, and again, and again, and again, and all you want.
All right. And I'm surprised that it's generating absolutely no interest from any of you turds. So, JP Ritchie guy, why aren't you interested?
So it's just ironic that he would type that comment when I'm appealing right to his face saying, well, I have made these videos. You're going to deny the existence of the videos or pretend you don't have any obligation here to pay any attention to the videos I make. Well, yeah, you do if you're going to do the mediator thing.
It's this obvious, clear, huge, gigantic kind of paradox about a fundamental principle. I mean, it's basically saying, right, that, let's see, what can you compare?
So I even give you an analogy, and you're still saying you're confused. So,
compare it to, there are many worlds, or there's no worlds. It's providing two options that just seem too ludicrous. I know there's no worlds because here I am existing in a world, so it can't be no worlds.
Just like there can't be free energy and nobody found it and it's so obvious. It can't be true. I mean, Professor Lowen's video has been up for 10 years or more, right? Nobody looked at it and said, wow, that's free energy. I'm making more and more momentum. Gee, I ought to take advantage of that, make that machine. I mean, none of them, nobody saw the equation and said, gee, that equation makes more momentum. You know, no conservation. I just make more. I don't lose momentum. I gain momentum.
But it can't be many worlds because that's just too silly.
And it can't be that Professor Lewin cheated and put a shorter little strip on the cart. I mean, that can't be true, can it? Or maybe one of his flunkies did it and didn't tell him. You know, maybe he can save face. So I guess the only thing to do is to take that clip, you know, and do the frame by frame and see if the heavier cart is actually going 2/3 the velocity. Because maybe it's only going half the speed.
Come on. This surprised me.
That still doesn't explain how the other cart has the energy to go the opposite direction, though. So that's the problem. Once you say it is going half the speed, the problem is, how does the other cart go the other way with 1/3 of the velocity? How did I transfer all the momentum plus some more extra momentum? So I used all of the momentum into the bigger cart. All of it went in. Plus I added some free stuff. And then where do I have any energy to cause the reflection? Where did I get that from? So, you know, then you got a problem. Because how did the spring create the energy going that way and not create energy going that way? So the spring had to have done that. So now we're back to maybe there is free energy and nobody figured it out. I mean, it's just so funny that nobody figured it out. Sheesh.
So it shouldn't be too hard to find. It should be back shortly.
Okay, so I won't play the rest of that. But anyway, I mean, plenty of detail, plenty of going into it. I don't know what else I could possibly say or how many times I could say it or all that crap. Fuck you. Just too silly. To ask for more, you know, no. You have to pay me, okay, to privately tutor you. I'll make you a private video if that's what you want. But you have to pay me. Fuck this. And it won't matter because you're just proving you're too stupid for the conversation. You're just too stupid to be a mediator. You don't know enough, you know, physics. All right. So, we'll pause again. We'll finish. What will we do? Well, it's 47 minutes, so I guess we'll just finish. All right. So, till the next time and such, this has been another DraftScience video presentation. You people are just impossible. Belligerently stupid.